Should we start?
Yep.
All right. Hello, everyone. It's my greatest pleasure and honor to introduce our distinguished speaker today, Professor Amit Sheth, whom I have known for many years, actually, as both a valued collaborator and mentor. Professor Sheth is the founding director of the university-wide AI Institute at the University of South Carolina and a fellow of the IEEE, AAI, AAAS, and ACM. His pioneer contributions to many areas have transformed how we approach artificial intelligence. And he also has co-founded 4 companies, including the first semantic search company in 1999, which developed technology similar to what powers Google's semantic search and knowledge graph today. His academic impact extends through the success of his 45 plus PhD advisees and postdocs who have thrived in academia, industry research, and entrepreneurship. So without further ado, please join me in welcoming Professor Amit Sheth as he shares his insights on the next generation of enterprise AI development.
Thank you very much, Yang. I'm delighted to be here with you. We are in a webinar. I don't know where all of you guys are located. I am just assuming that being a significant and large company, you have employees and participants throughout the US and perhaps beyond. Thank you for joining me. I hope I'll be talking about something that is somewhat different. It will have a little bit of a different viewpoint. So I'm going to talk about what I call making these AI systems more intelligent, which would mean more reasoning, for example, more robust and trustworthy. And if you think about it, for enterprise applications, that's what you will need much more of. I'll present to you an architecture and some views from the implementation of what we call custom, compact, and composite AI systems using Neurosymbolic approach. And we have some significant enterprise class applications also developed using this approach. So hopefully you'll find some ideas that will make you ask some more questions. LLMs are, all of you know of LLMs if you're attending this, and they shine in some applications very well. They're great for content generation, for textual coherence, for natural language processing and interactions. Things like entity extraction, information retrieval, and productivity and assistive tools. I know, Salesforce, for example, is very active in agentic AI. So many enterprises are interested in and trying to work with generative AI. There have been some very good applications too. At the same time, there are a lot of risk and a lot of challenges in using AI, and some of these have received attention, others have not in a very concerted way. I'm sure all of you have heard about and are aware of hallucinations. OpenAI admitted that their latest model hallucinate 1/3 of the time. Something to think about. This is the latest of what we have. When you do AI workflow integration, the enterprise workflows are quite different and quite demanding, and the availability of certainty with the generative model, or lack of certainty, reliability, consistency, and variety of other things, explainability, I think you could quickly lose the track of where the error was generated, how the error propagated from agent to agent, and there'll be a lot of issues. Deskilling is being talked about recently more and more, um, uh, and yeah, skill atrophy across career stages, and other challenges that are out there. Um, Areas where LLMs are not great are, so they are designed for words, they are data hungry. What if you don't have a lot of data? What if you are working in a domain that where there's not so much public data on which the pre-training could have been done? That would you be able to make a local model and fine-tune it? Opaqueness, this has remained a challenge. Just today I came across one of the top AI researchers talking about the fact that there isn't, we don't know how it works, right? And there are different levels of it. Some we know, misalignment, they can create results that don't value societal value, ethical standards, regulations, and compliance with them. And some of the domains, they may not have enough data. So as you see today, a lot of press that has been obtained and work has been done is what I would call consumer-centric applications. You might have question answering, you might have coding, you might have content generation, summarization, things of that nature. There are some enterprise class applications, but a lot more needs to be done there. On the other hand, for business applications, for enterprise applications requiring planning, reasoning, cognition, there isn't as much work. And we'll see the reasons why there is a way to go. One very important thing, which I recognize a little while ago, but which Gartner put very well, just I think about less than 2 months ago, early in 2025, they came out with this prediction that by 2027, more than 50% of Gen AI models that enterprise use will be specific to either an industry or business function, up from about 1% in 2023. So compared to the general purpose models trained on massive amount of everything on the web, and then restricted or modified or improved through RAG or fine tuning or instruction tuning or other methods, there'll be much more use of models and basically AI systems created specifically solve that class of enterprise applications. There's a professor at Stanford who also has a company, Yo Shoham, and he said this very well. You know, what if you have an AI system that is brilliant 95% of time but ridiculous 5% of time? For in enterprise, you are dead in water, right? So there are many applications where uh, saying that I can get 70%, 80%, even 85, 90% accuracy just doesn't fly. And it's not just accuracy, it's a lot of other capability, as we'll see. So, I mean, very recent articles, a 2025 BBC study showed that 51% of all AI answers to questions about news were just to have significant issues of some form, and many of the things of that nature. One, you have a question? Or Sophia has question, sorry. Go ahead. Okay. So, all right, the hallucination, you have seen that, and accuracy issues also, some of you are aware of it. Today, to build large models, you need an army of people and massive investment. So, state-of-the-art models involve 50 to 250 researchers and engineers. I would predict that future models will be compound and composite AI, future systems will be compound and composite AI systems, which will involve use of a series of small custom models. And that is the journey I'm going to talk more about. So here are some of the issues. I don't want to belabor this point too much. Inaccuracies, the complex enterprise applications require robustness and trust. The understanding. So, LLMs are great at natural language processing, but they are not good at natural language understanding. They don't understand anything virtually the way humans understand. There are huge privacy and security problems. That's why more people are interested in having their own models deployed in their own environment, potentially on a laptop or custom hardware. They have consistently overpromised. Again, this is not to say that there are not a class of applications for which these are great. As I said earlier itself, content applications, they're great. Creative applications, they are great. But enterprise applications require, you're not going to have a lot of errors, let's say in a manufacturing plant, but any error that occurs, any exception that occurs will be very costly. So those will be rare errors and you have to find them, handle them effectively. That is, that requires a different kind of system and architecture than these LLMs. Lot of vulnerabilities. So today agentic AI and AI workflows are very, very popular. For now, research, current evidence is that they struggle with complex knowledge integration reasoning tasks without built-in domain structures. Accuracy of complex queries is extremely poor. Researchers found that these systems may achieve pretty low accuracy on a set of very complex business questions, and fail on questions requiring understanding relationships. And by doing certain things like augmenting these systems with knowledge graph, accuracy can substantially be improved. Many more things can be done, which I'll talk about today. So here's my broad observation I start with. There are a few applications where current AI, Gen AI solves a problem well, but many more where humans use AI to solve the problem. And that does improve human productivity and efficiency. And but by being human in the loop, you are taking care of some of the problems that the AI systems themselves have, the large language majority AI systems currently have. So full automation is something that you don't expect yet for many cases. For some, you do. You remember, most of you should know, in 2012, they were feeling that, oh, skin cancer will be solved problem with AI, with deep learning. Well, it's still not a solved problem. One of the top Silicon Valley venture capital, Vinod Khosla said several years ago that AI will replace all the doctors. Well, that has not happened. While you can find all the taxis in San Francisco area, robo taxis, full self-driving is not possible yet, and not I think people are not sure exactly when we'll have that and if we will have that. So with regards to LLM, I think they are being quickly commoditize, and which is good. Um, and what today happens is that there is a lot of effort post training to make LLM based solution, generative AI solution useful. I think there is a better way. We'll talk about them. Focus is, the action is on frontier models. These are highly specialized models, and they solve very specific problems. And for that, you may or may not use generative AI solutions, or rather may not use large language models. And as we deal with more and more complex applications, um, the action is in creating these composite AI systems. They can have multiple models themselves. The models themselves can be heterogeneous. I'll talk about them with specific examples. And that they will then try to perform complex tasks that many enterprises have. I'm guessing that a lot of business that Salesforce has is more in this form of enterprise application rather than the traditional content applications and generative AI. So by end of 2025, we'll stop talking about models and talk about tasks. So recently we came out with this C3AN approach, custom compact composite AI using neurosymbolic approach. And we have identified the prior generations, but GPT, ChatGPT, Crew AI, GitHub Copilot, and then the examples that I will discuss today, like MAIC and Nourish, you'll see these are enterprise grade applications, complex enterprise applications that require the class of AI, the type of AI that I'll talk about more of today. And there is some written material available on that. So what are these? So compact is that, I'm sure you are all hearing more and more about small models. And there are a series of techniques that have evolved and are evolving, where we're increasingly finding out that we can make these models smaller, much smaller than what initially started out with trillion parameters and so on and so forth. And it has many advantages. It can be deployed in resource constrained environments. It would be deployed with higher, complete privacy and confidentiality and security. And it would have far smaller, development, deployment, and operational costs. The next is custom. So these are systems tailored to solve domain specific problems, um, and they will involve domain specific knowledge and workflows. They will adapt to user specific constraints and requirements without extensive retraining, and they will ensure flexibility in incorporating new rules or guidelines with minimal overhead. Then comes composite, where you integrate multiple AI modules. You don't have, it's not an application that is largely solved by a large language model. Actually, you'll have series of models, small models or modules. Some of them may be AI models. They would use neural networks and symbolic models. They will support complex tasks by orchestrating various specialized components, and they will enhance decision making by combining diverse data sources and reasoning methods. They will be neurosymbolic. That means they will combine both neural network based and symbolic reasoning based AI for advanced decision making. Again, they will use domain specific knowledge along with pattern recognition and incorporate human feedback and expert knowledge into the learning process. There have been several um, recent examples where the evaluations have shown that neurosymbolic approach has done much better compared to LLM alone or generative AI solution alone. So for the example of medical diagnosis for diabetes, is showed that it went up 52% in accuracy, that it supported explainability in enterprise QA for insurance data sets. Again, with knowledge graph augmentation, you got much higher accuracy. For anomaly detection, uh, you again got far better results. And for in autonomous driving, you found that there was a lot more awareness of the objects in the real world, and many errors were prevented compared to pure LLM driven planning for driving. So in what I'm going to talk about is not a matter of future research. A lot of things can be done now, and I think we are gaining quickly more experience. In my case, in my team, we have been sold on Neurosymbolic for quite some time. So we've been one of the leaders, especially in use of the knowledge graph for Neurosymbolic approach. We've been working for quite some time. Uh, I remember a paper I had in 2016, knowledge will propel machine understanding of content. And the other paper I had was this one shown at the bottom here, semantic, cognitive, and perceptual computing, a paradigm that shapes human experience. It had components of what eventually was known much better as System 1 and System 2. So this paper preceded my exposure to System 1 and System 2, and clearly Daniel Kahneman did much better job in describing these two things about System 1 perception based AI, where the neural network works very well, and cognition, where symbolic AI does much better. But to give you a very simple example of what is the power of this is that think about your understanding what I'm saying right now. You are utilizing your understanding of language and grammar. So you have lexical understanding and lexical knowledge. You have linguistic knowledge. You have common sense knowledge. You have broad general purpose knowledge. You know San Francisco city, you know what major companies are in San Francisco, you know what is it good for, what is bad for, a lot of things you know. And then there are domain specific knowledge. For mental health, it could be DSM-5. For broad medical thing, it will be UMLS, and so on and so forth, right? So we humans use all of them. Can you imagine yourself trying to understand the language without all of this knowledge and background? So then why would you expect LLMs to be a great system without having all of these things, right? So neurosymbolic systems, what they do is to, on one hand, utilize neural network and deep learning in system one kind of processes, there where you have probabilistic processing, and when you create vectors and large parametric space, that's when you learn from the data and are able to apply at inference time. And on the other hand, you have knowledge graphs, demo nodes, and edges, and you have logic. And you may have, let's say, in particular, let me give you a very solid example. When you go and see a doctor, uh, depending upon the specialty of the doctor would be using medical practice guideline or a clinical protocol. If you see an asthma specialist has a set of protocols, or you might call same as regulation, that they need to follow. If you go to see an expert in another discipline of medicine, they would have cardiovascular, let's say, they would have their own protocol of how to classify a heart failure or heart condition. So those are guidelines, and we capture them as process, as part of our knowledge representation, and ensure that our AI system adheres to that, follows them, complies with them. Just the same way doctor is supposed to do that, your AI system should do that if the AI system is being used for that application, right? Your vanilla LLMs won't typically know that. There will be there will be variations between LLMs. For example, I work with a startup in healthcare space, and I noticed that Google software, particularly Gemini 2.5 Pro, is much better, has much better training on healthcare data, medical data. So for example, it knows ICD-10 code very well, and some of the others don't, and that is partly because, as a search, as a developer of most popular search, 5% of Google queries are health queries. So they developed a comprehensive knowledge graph separate from their Google knowledge graph, and they have long-standing experience in dealing with healthcare data, and that they have used. So in that sense, in a broad-based system, they have incorporated more of the medical knowledge than others have. With the C3N framework that I just mentioned, and I'll talk about it more, we are trying to get an AI system that is more intelligent, more robust, and more trustworthy. And we identified 14 foundational elements that map to, or that contribute to intelligence, robustness, and trustworthiness. So you would have come across many of these perhaps, but not at one time. Reliability, consistency, alignment, analogy, abstraction, causality, instructability, reasoning, planning, grounding, explainability, attribution, interpretability, and safety. Many of them, you would have heard of them. My assertion is that you look at any enterprise application, you'll need a plurality of these. You'll need quite a few of these, if not all, many of them, some more than others. And my other assertion is that generative AI, LLMs, have not paid adequate attention to, or are not that so good at supporting this. So there is a lot more work to go before we'll have many of these things. Another thing I will challenge is that if you are working on enterprise application, ask your customer which of these you are willing to sacrifice. Forget about the solution and start with LLMs, but ask which of these they want. If there are multiple classes of healthcare workers, they would say we need alignment so that the AI system adapts to the need of each different class of healthcare worker. In some cases, they would say we need reasoning, but when you go deep down into reasoning, so-called reasoning models in current AI, R1 or O1, they do only a fraction of the types of reasoning that are there in the real world. That very big fat word reasoning is being branded around very, I guess, easily, but in reality, it is doing a disservice. The kind of reasoning that current AI systems do, current language models do, it relates to the kind of reasoning task for which they can find a lot of data and adequate data, maybe for math reasoning, maybe for some, and certainly they do well for language reasoning, but there's a lot more than that. Grounding, extremely important. Does it map to the real world? Or are we just simply in the cyberspace for all the data that has been collected without the context for that data? Right? Safety, a very, very important issue. Explainability. Explainable AI was a very big thing just 4 or 5 years ago. I'm hearing less of it, but I think that's not because there is not enough need of it. It's just because current systems are very fairly poor at user level of explainability, application level of explainability. I'll give you an example. So what we are doing, my team is doing, is to develop this a platform. You guys may be everyone here probably may be aware of machine learning pipelines and the software that help you develop deploy machine learning pipelines. Here we are developing a platform that will allow you to develop and deploy these enterprise applications using C3 framework. So it has a lot of different components to deal with data and knowledge and pre-processing, and just like LLM training, but many more things that are involved in developing these kind of systems. So now I'm going to give you some examples of mission critical applications. I'm going to play a very short video. So these slides will be available to you, and you'll be able to go through these applications are slightly longer videos, and but I'm just giving you some.
Meal impacts your health, so why not make every choice count? Introducing Nourish, your personalized AI co-pilot for smarter eating, powered by a custom, compact, and neurosymbolic model. It offers real-time personalized dietary analysis. Nourish is a specialized AI model for food and nutrition. With access to millions of recipes and semantically grounded knowledge from diverse sources, including disease-specific insights and personalized health information, it offers tailored meal recommendations and recipe modifications designed to meet your unique needs. With the power of the Common Metadata Framework, in collaboration with HP Enterprise, we ensure traceability and AI governance, so you know every decision is safe, transparent, and trustworthy. Nourish is more than just a recommendation tool. It's your trusted co-pilot for healthier living. Together, we're shaping a future where personalized nutrition is available to everyone. MTSS is a 3-tiered proactive intervention system designed to help schools support students through key components like universal screening at the start of the school year to identify student needs early, tiered interventions that adapt in intensity based on student progress, continuous data collection for ongoing assessment and improvement, a school-wide approach to consistent expectations and supports, active parent involvement to ensure holistic student growth. The MTSS team is a collective effort involving teachers, counselors, mental health support staff, administrators, and more, all working together to create a supportive learning environment. But what if an AI system could enhance this teamwork? That's where the MTSS AI system comes into play. To meet the specific needs of the AI system, we have 3 unique features: custom, compact, and neurosymbolic. Let's break down how these elements work together. The system is custom built, trained on domain-specific data to act as a specialized concierge.
Okay, so we'll go back. And the third one is very exciting in manufacturing. All right, so the one application I introduced is this so-called MTSS, and it's very interesting because first of all, MTSS is a law in the state of South Carolina, and it's also utilized in 80% of the states in the US. So it's not something that that's something low. It has very very wide application. Currently, MTSS framework is being practiced all manually, and we want to change that, make it far more efficient and productive. So the students can get 3 tiers of services: general core instruction, targeted intervention, and intensive interventions. And there are variety of stakeholders, educators, administrators, counselors, family, that are involved in making this possible. And when you look at MTSS, you can find significant and clear needs for grounding, for in alignment, for example, with respect to broad variety of the users that we identified, a variety of reasoning that I have identified there, and instructability. Also, use of knowledge is very critical in making your system explainable. So this is an example of not from MTSS, but MTSS does involve mental health, and so this is mental health example. But you can see the text. From the text, your components of the text are mapped into concepts in the knowledge graph. And the knowledge graph gives you richer, information. For example, feeling hopelessness is a type of level of mood, and and then there is a definition for OCD that involves obsessive, intrusive thoughts, ideas or sensations, and this allows you to understand why the system, AI system, considers this to be an example of OCD. Is that why that classification, right? That explanation is very critical. If you cannot explain to the clinician that this is why I consider this to be STD, and just say, oh, my black box super duper AI has classified this as OCD, they won't use it, right? As we this is something I will not walk into detail today, but you'll see that this particular application involves all these 14 elements, requirements for all of those things. The safety would involve prohibiting psychologically harmful interventions by combining domain rules and counselor approval. Grounding is aligning each suggested intervention to students' schedule and local resource availability. Alignment is adhering to students' behavioral objectives, referencing distinct frameworks and teacher courses. So, teacher council. So, there are need for each of them. Now, all of you probably are aware of Autogen, the leading framework for agentic workflow from Microsoft. But there are a number of issues just using on its own, and you can be misled, or you can get false information, or you can get suboptimal thing in many different ways. So what you need here, if you see on the right hand side, is the a planning setup that uses process knowledge, and that is the one that guides all of the steps, which then leads you to a far more relatable and reliable and trustworthy outcome. One of the examples in this case of diagnosis of depression, this one is demonstrating the use of PHQ-9. So if you go to a clinician, you'll be given very likely this questionnaire, PHQ-9. There are 9 questions, and you give 0, 1, 2, 3 for each of them. And then based on the the scores, you are classified as having what level, no depression, mild depression, moderate depression, or severe depression. So now in this particular case, we we are just in the process of completing the evaluation, but we got fairly poor precision and recall just using Autogen. Then we added chain of thought, then we added process knowledge, then we added process knowledge with future examples, and now we are doing C3N. So you can see that bringing in knowledge can substantially improve. So that's the neurosymbolic part, and then we will be showing how much of the custom models and compact models can also support or not support this kind of results. In the smart pilot for intelligent manufacturing, we are addressing number of issues, including currently this this AI system that I use will be siloed, and there'll be solutions for anomaly detection, causal discovery, and isolation. It needs to be all integrated, and they would not support the reasoning such as root cause and explanation. You want to do this in real time, and you want to have explainability for higher trust. So in our this is a good example of composite AI with agent-based copilots, where what you can see is that there are 4 copilots here: predicts X, causal lens, predicts is for anomalies ahead of the time, causal lens is for root cause analysis, and causal discovery. Foresight is for forecasts of products, product analysis ahead of the time, and such. And you can see on the right hand side the composite AI architecture, and you'll see that they have a variety of models involved. You have a RAG base module, you have time series foundation model, LSTM, you have image related vision net vision model, and so on and so forth. So you can see that there is a broad variety of things that come together to make this system possible. This shows the deployment of this system realization. It has various components. It has a 21-step production procedure or process. At each step on the bottom right, you have data points at every timestamp. So of course there are many timestamps. So you have all of these, and then you can see that pictures can be very low quality and noisy. So there are many challenges that you have to address in this kind of context. Diane, you have a question? Okay. And in this case, we have discussed these 14 foundation elements for each of them. And you can see, so reasoning, we need to combine causal structures, sensor rules, and semantic metadata from the ontology knowledge graph to deduce likely root causes behind anomalies. So that's beyond simple correlation. There's an example of causality, and so on and so forth, right? So you can see if there is an error found, then you want to replan and avoid the error next time through the process and get the results. Perhaps the most challenging problem I will discuss is this one, Nourish, which is this disease-specific diet recommendation. So here, what you are trying to do is that you are facing a recipe or a food item to eat, and you want to find out whether it is advisable that you consume this food, or what alternatives you have. If you are cooking at home, what different cooking method you can use, what different ingredient you can use. For example, can you switch a type of oil, canola oil versus some other oil? Can you reduce the salt? Can you is potato okay with your glycemic index related constraints? In your end result may be recommendations like potato has healthy carbohydrates but high glycemic index, and there are many sources to get that knowledge. Canola oil is unrefined good fat. Deep frying introduces trans fat from US FDA. Frying leads to vitamin loss, allergens, and calorie within limit or not. So it uses ingredients, it uses cooking method, it uses interactions between various components, whether ingredients or some other thing, ingredient or cooking ingredient and cooking method, and of course it uses a lot of data from the past and that are collected, and domain knowledge of variety of kind. So in this case, you see substantial need for grounding, instructability, alignment, abstraction, reasoning, and you may for example talk about uh, beef, but then you say you want vegetarian, then system knows all the other elements that are meat and then avoids them and gives you one of the popular substitution, let's say cauliflower instead of pork, to do what you want, and then you select that, right? So this particular system really is developed with all the domain specific knowledge and data. It doesn't have a lot of other fluff. You do have to there are things like having the fluidity of language, for which you do want to utilize generative AI, that you can do by having the domain specific processing, and then just in the construction of the natural language you can utilize the results of large language model. Um, in this particular example, you would have dynamic multimodal process knowledge graphs. You can see on the left hand side knowledge in the variety of representations. So disease specific knowledge graph, cooking taxonomy, glycemic index, they all come in a different variety of form that your application would deal with. There could be rules in the bottom right, and there will be here you have and you will have unstructured data as well as structured information, and you deal with all of them in a very effective way. And then you say that, oh yeah, this is a grilled steak taco, and you're looking for an alternative. Then how do you come up with an alternative while meeting variety of constraints that you have? That's the kind of reasoning that the system can do and support. Now you would have the neural component for sure. For example, on the top you are seeing image to text, and there are systems, quite decent systems available that can generate these texts very well. But then you will see that there are a variety of models involved here. So you can see here ingredient extraction rule based model, cooking action extraction neural network model, and relationship extraction neural network. And then they will be working with the knowledge graph. So some of the processing can be a neural processing, like embedding based mapping function, which can be reasonably done by neural network. In other cases, you need to be a lot more precise and have rule based or logic based reasoning for what you need to do. So this is that I just showed you the parts of the application that use neural reasoning. Here is one that uses all symbolic reasoning. There is individual set of inferencing that are happening with different components here on the left hand side, and then there is a compositional reasoning or knowledge graph based Bayesian inferencing that brings together all of these components and does the more effective reasoning. So we have different components here in this thing: posterior, prior, likelihood, evidence, and then we do the reasoning. The output is explainable and traceable. So ingredients in the context of diabetes, reasons to recommend or avoid or have it with caution. So the system will come back with something that you want to eat, but then it will say, well, what is the impact if you read it and why? And there will be also things on it will explain to you ingredients and cooking methods and replacement and so on and so forth. So there are also foundation models, foundation elements for each of these here. For example, explainability clearly states sugar content impacts blood glucose, referencing medical research and recipe data. Or attribution, it cites nutrition database plus dietitian oversight in final suggestion, and so on and so forth, as you can see. And this involves a variety of, we evaluated reasoning with 9 LLMs and found that they don't perform very well, and they fail for the number of reasons that they fail. And here, you can see broad, a type of variety of reasoning that this application involves. Now that leads me towards the end of this particular segment. In Salesforce, I mean, this is just I really didn't do deep research or anything like that, just a light bit, but we found, for example, you have agent force, and reasoning with Atlas, and you can see some of the headlines, probably you know all of them very well, and we think that the principal way to consider these 14 elements of C3 and can aid in enhance safety and trustworthiness of the AI. Neurosymbolic approaches, when we have variety of ways to combine neural network and symbolic AI in deep, semi-deep, and shallow forms. The human in the loop feedback can be used for domain specific adaptations. So, and there's just some of the terms that I highlighted that you guys are already aware of and working towards, and perhaps what I discussed today would be a good reference to have or compare with as you continue along those dimensions. This is a brief, overview of my, intelligent, robust, and trustworthy AI team at the AI Institute of South Canada. So in the center, you can see a broad variety of AI topics that we work on, where we do foundational work, and you can see on the outside a very large number of translational work we do. And one of the interesting thing about my style of work is that, and my team's work is that everything we do has a real world problem, like the ones you saw today. I did not discuss the examples. So this C3N work, we are already working with some startups, and they are developing their models using our platform and what I discussed today, in very specific verticals like finance and other things. And so we are relatively, we pass from, go from foundational AI research to highly applied research to commercializable technology. 3 of the 4 AI companies I did were all involving developing research, doing research with my students and getting the IP, and then licensing that to start the companies. 2 of them I ran myself, other 2 I didn't. And having the access to real world problems, real world data, real world domain knowledge, and the ability to evaluate the results with those domain partners or application partners gives a lot more confidence in not just the research but also technology that result from our research. So that is something I'm happy that a good percentage of my students have gone on to become entrepreneurs, and of course some have gone to tier 1 universities and others have gone to industry research labs, or even industry R&D. Okay, so this is my current team, and in particular Revati, Kaushik, and Venkatesh did were more closely involved with the presentation I gave you today, but all of this is a group effort. We grew quite a bit in first 4 years of the AI Institute after I founded it in 2019. All right. So with that, I think I'm well in time and happy to.
Hey,
Take
Professor
questions.
Amit, we have a few questions in the chat. The first question is from Iran. The human brain decides which domain-specific models, right? How would neurosymbolic approach decides which domain models to use?
I did not quite get the question. When we develop one of these applications, we just today, no, this Friday there'll be a major presentation of our Empower tool. Let me show you just in a moment. So here we have a professional grade tool for knowledge graph creation platform, and you can develop fairly sophisticated knowledge graph. One that we developed for pharma has 10 million nodes, and we extract the knowledge from unstructured, semi-structured, and structured knowledge sources. So essentially, you you are solving a particular problem in the enterprise, and you identify existing knowledge sources that you can utilize. Like in healthcare, you may say, I want to use RX norm and I want to use UMLS, or the knowledge in that structured form or appropriate form is not available, so you use a platform like Empower to develop the knowledge graph with a good bit of um, automation, I would say, or semi-automation. You saw, for example, in my application on, this we just saw this. This one here. It had so many different types of knowledge, and we found this knowledge from many public sources. So we had Mayo Clinic, or we had FDA, or we had so here you can see US FDA. I had consulted with or advised a company called Edamame, which is world's largest nutrition database. So there are a whole variety of knowledge you have to find from multiple sources, and then that's why we have to create this composite system, so that we can use the right knowledge at the right time. And as I also demonstrated to you, within a single composite AI system for an enterprise, you have to use models that do different kinds of processing. So this example has this in this gray, three different models. In this one, you see there are multiple different components using different models, time series model, or image related vision language model, and so on and so forth, right? So many different models, they use different knowledge. All of them have to come together, and then having a platform like what we are developing. Although I'm unable to discuss the platform in lot more detail, uh, I could discuss it with a partner, but there are a lot of different things that go into creating this platform, so that you can collect the data, collect the knowledge, update them, collect the verification with the experts, very important part, so you can do the safety checks, and then allow creation of all the models, use the agentic workflow to bring all the things together, understand data flow and control flow and data flow in orchestrating different agents, so many different things, reuse variety of components, all of them have to come together. So there is quite a bit of machinery you need to create these models, especially as you start talking about such complex applications that have, and you see these are very, very, fairly complicated applications with many, many moving parts. So yeah, I hope I answered some of it. Is it human to decide based on research which models to use? I mean, human decision making is very important as you architect your composite AI solution. So yeah, in that sense it is. But just look at this presentation. I have given so many different examples. So um, yeah, at this point I would say yes, it will be human that will decide what model to use, what will be the right. You have to look at the data you have available, you have to look at the right AI techniques, whether it's a neural network technique. I showed you an example, that there's a whole this whole slide is about neural components, and then this whole slide is about symbolic components. So you'll have to learn, you have to use that. Okay.
Yeah, I think we are right on time or even past 1 minute. Yeah, let's thank Professor Amit Sheth for this wonderful talk. All the slides and the recording will be shared. So yeah, thank you very much, everyone. And all the questions are really good. And thanks, Professor.
Okay, I'll read this certain. I don't remember this one, but yeah, I'll look at it later on. Thank you very much. And I guess we are meeting again on the other link, right?
Yes, yeah.
For more details.